What's going on, guys? We have a question from linear equations right here. The question is asking, consider the following system of linear equations, and A is asking, find all x and y such that linear system has no solution, and next one is infinitely many solution, and the third one is unique solution. So let's see, we can unique solution, right? Let's see how we can solve this one. So if we see this one, um, this one is not in the Gauss elimination, like this one has number, so we don't have control over this x minus 1, right? So in order to find this, in order to solve this and find the exact no solution, infinitely many solution, unique solution, we have to solve this one to we have to bring this one to zeros. Then only this is in Gauss elimination format, and all the value below the diagonals are zero, so we have the control over this, right? So let's see. So in order to do that, I had to do one more step to solve this problem. 130, I'm copying the same question again, so I can do the things. 1305 and 01 to 1 and 0 to x minus 1, and this is y minus 6. So what I am going to do is I'm going to make this one equal to 0. So in order to do that, I can multiply the second equation by -2 and add it to the third equation. So 1305 and 01 to 1, and for the third equation I'm going to multiply the second equation by -2, -2 e2 plus e3. So this will become 0, and -2 it is going to be -2, -2 plus 2 is going to be 0, and -2 times 2 is going to be -4, -4 plus x minus 1 is going to be -4 plus x minus 1 is going to be x minus 5. Let's see, -4 plus x minus 1, right? So x minus 5, right? So this is going to be x minus 5, and -2 times e2, -2 times 1 is going to be -2, -2 plus y minus 6 is going to be y minus 8. So this is my final value. Now I can solve these questions. The first question is asking, find all x and y such that system has no solution. So we know if system has no solution, it means these three numbers should be equal to 0, and if the final has a number, uh, like if these three are 0 and this has a number, then only it has no solution, because it means 0 equal to whatever the number. It doesn't make any sense. So in that case only it's going to be no solution. So we know when x is equal to 5, this will become 0, right? So this is x is equal to 5 and y is not equal to 8. X should be equal to 5 and y should be not equal to 8, because if it becomes if y is 8, then this is 0, and if this value also 0, this means infinitely many solutions. So that's the only exception. Y shouldn't be equal to 8, but x should be equal to 5. That's the answer for the A question. And the B question is asking, find all x and y such that the system has infinitely many solutions. So as I discussed about before, if you want to get infinitely many solutions, you have to get everything 0. So in order to do that, I had to this one has to be x should be equal to 5, then only this will become 0, right? 5 minus 5 0, like, and y also has to be 8. So for this one, x is equal to 5 and y is equal to 8. So in this case, this equation will have infinitely many solutions. And the last question is, find all the x and y such that the system has unique solution. So unique solution mean like this all shouldn't be equal to 0. Then only this system has unique solution. For example, if this one is 0, then if this one has number, then no solution, like no solution. And if this one is 0 and this one is 0, infinitely many solutions. But if this one has number, and this can be 0 or any number, uh, that mean it has a solution, unique solution. So it means x shouldn't be equal to 5, but y can be any number. It can be 0 too, right? So x shouldn't be equal to 5 and y is any real number. So that is the answer for the last one. I hope you guys like this video. See you next time.